We're now going to multiply a vector in component form by a positive constant. This means that we're multiplying the I and j components by the constant. So in our example, we have a vector A, which is in component form, and we want to work out the vector 4a. So first of all, the vector that we're looking for is 4a, so that's our title. We're going to replace vector A with its I and j components, so that's 4, and then I'm going to open brackets because the I and j components belong to A, so in brackets we've got 3i plus 2j. So straight away we're going to be multiplying the I component by the constant, and we're going to be multiplying the j component by the constant. So 4 multiplied by 3 is going to give us 12i, and then 4 multiplied by plus 2 is going to give us plus 8j. And these are the I and j components of our answer vector, which is 4a, so we're going to put those in brackets. And that's our answer. So that's how you multiply any vector by a constant. Now, there is a meaning to multiplying a vector by a constant, and we're going to look at the meaning now. So, again, if we take our example here, we've got the same vector, the original vector, a equals 3i plus 2j, and we want to draw the vector 4a. So again, we're multiplying the I and j components by 4. So what I'm going to do is physically draw the original vector, and then physically draw the new vector. So let's take our original vector. So it's 3i plus 2j. So I'm going to pick any point at all on our grid with I and j axes. So I'm going to pick, say, a point here, and that is going to be the tail of vector A. So to get to the nose of vector A, we have to move 3 units to the right. That's what the I component tells us. And then we have to move 2 units up. That's what the j component tells us. So start at the tail, move 3 right, 1, 2, 3, and then we're going to move 2 up, 1, 2. And that's going to be the nose of vector A. So let's join them together. And again, put our arrow on it. The arrow always points at the nose. Label it. That is vector A. Again, we can put the I and j components on as well. So remember, the I component is the horizontal bit between its end points, its tail and its nose, so it's 3 units. And the j component here is the vertical bit between its end points, its tail and its nose, so it's just 2 units. And that's our original vector. Okay, what I'm going to do now is draw the new vector 4a. So remember, when you multiply a vector by a constant, you multiply the I and the j components by the constant. So the new vector, remember, is going to be 12i. That's when we multiply 3 by 4. And then plus 2 times 4 is going to give us plus 8j. So again, pick any point on the grid. I'm going to pick a point, say, down here. And that's going to be the tail of the new vector. So to get to the nose of the new vector, we'll have to move 12 units to the right. That's what the I component tells us. And then we have to move 8 units up. That's what the j component tells us. So 12 right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 8 up. 1, 2, 3, 4, 5, 6, 7, 8, and that is going to be the nose of the new vector. So join the tail to the nose. And again, we'll put our arrow on it. The arrow always points at the actual nose, and that is the vector 4a. And again, we can put our I and j components on it. So again, the I component is the horizontal bit between the end points of the vector, between its tail and its nose. So remember, it's 12 units. And the j component is the vertical bit between the end points of the vector, between its tail and its nose. And again, it's just going to be 8 units. And this is going to be our new vector. So what we did was we multiplied the original vector by a positive constant, and the positive constant was 4. Now, what you're going to notice is that the length of the new vector is going to be 4 times the length of the original. If you took a ruler and measured the original vector, and you took a ruler and measured the new vector would be 4 times as long as the original one. So its magnitude is 4 times as much. Not only that, you'll also notice that the I component of the new vector is 4 times the size of the I component of the original one. And likewise, the j component of the new vector is 4 times the size of the j component of the original vector. So in other words, when you multiply any vector by a positive constant k, where k is greater than 1, the length of the new vector will be k times the length of the original one. The I component of the new vector will be k times the length of the I component of the original one. The j component of the new vector will be k times the j component of the original vector. Not only that, you'll notice that both vectors are parallel, and you'll also notice that the arrow direction of both vectors are the same. So that's really important. You have to understand that when you multiply any vector by a constant.